Hello, and for today's problem, we're going to be doing number 20, valid parentheses. So given a string s containing just the characters like square bracket, regular bracket, and curly bracket, uh, determine if the input string is valid. And it's valid if the open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. And then we're given this as an input. So we're given these examples. So in this case, we have the curly bracket over here, or like the regular bracket over here, and it's closed by here, so the output's true. For all of these ones, it's equal to true as well, because it's all closed, and for this one, it's false. Okay, that makes sense. Um, Something as an example of an invalid one would be, okay, so this would be valid. Um, like this would be invalid. Okay. Um, hmm. A way to do this would be to have a stack. The stack that you would keep appending every single bracket to as you traverse the string. So first we would traverse the string, and then we would append. For every single element, we want to add that to the stack. If we want to, what we want to do is we want to add every opening bracket to the stack actually, because yeah, just add that to the stack. Every time we encounter a closing bracket, what we want to do is we want to pop the last element from the stack, check to see whether or not that element from the stack is the respective one of of the closing bracket. If it's like the one that the closing bracket needs, if it is, then what is it? Then like it's closed, and then you can like remove those items from the stack. We'll remove that like bracket from the stack, and if it isn't, then that means the string invalid this is not valid for but for like number 3 over here. So it has to be closed. Yeah. Okay. And they must be closed in the correct order. Okay. So to give a little bit of a visualization of what I'm talking about, I'll make a hash map over here. For example, we have we have this closing bracket, and for this one, we need this bracket in order to have it be able to close. So I'll do that again for curly bracket and then the square bracket. So with this hash map, what we can do is then like traverse to the string. So for value in string, we want to check to see whether or not the current character in the string is a closing bracket, and we can do that by checking to see whether or not it's a key using this. So if v not or in, if it is in the hash map, that means it's a closing bracket, and we want to pop the latest element, like the last element from the stack. Otherwise, we want to append it to the stack. So we'll add an element over here. So we'll make a stack at the top, and then we'll append the element to the stack. And then if it's a closing bracket, then we don't want to append that to the stack, and what we want to do is what we want to do is pop the last element in the stack and check to compare and see whether or not it's what it needs in order for the string to be valid. So we can do that like so. V. Check to see whether or not someone needs, and we can do that by doing hash map. Oh, sorry, not hash map.pop. If stack.pop is equal to hash map brackets. So value. That means it's valid. So then we do continue. Otherwise, we return false. And then we just keep appending to the stack. And then at the very end, we want to see, is there any element remaining in the stack? If that element is remaining in the stack, then that means it's an invalid one because there's still some open brackets which need to be closed, and that wouldn't work. And if it is empty, that's when it's valid because every bracket has a corresponding one. So okay. So to go over this problem again, let's say we have something like this. So we traverse through the first element in the stack. We check to see if the value is in the hash map, and it's not because it's an opening bracket. So then what we do is we skip this entire sequence and then we add it to the stack. We move on to the next one, and then we check to see it's a closing bracket. So it is in the hash map. What it does then is it pops the last element, the last element of the stack, which is this one, and then checks to see whether or not it's its corresponding one. So in this particular case, it is because the value of the current character, this key, is the opening bracket, which is what it is. And what it'll do is then continue, and it's popping that element from the stack. You would then move on to the next one, it'll do on, so forth, and so on for the rest of them. So, yeah. In this case, the time complexity would be O of n because you're traversing through every single element in the string. And then the space complexity would also be O of n because in the worst case, you'll be storing everything within the stack. So let's go ahead and submit this code. Oh, alright, forgot my comment. Well, my comma's over here. Oh, okay. Oh, well, we need to have a check to see whether or not the stack exists. If stack. Okay. We have an error over here. Oh, right. We need to also indent this to make sure it's within the for loop. There we go. Okay. Yep. Well, thanks for watching.